Hello all and welcome to this video. So in this video, we are going to continue our discussion on recursion and array and solve a variation of the question which we did in the last video. So I'm pretty sure that you must have written the code for last index of a number. If not, please make sure that you check out the solution. Now, the question which we are going to solve in this particular video is actually a variation of the last question only, in which we are now required to find all the indexes of a number, right? So in the last video where we were concerned with finding the first or the last index, here we have to make sure that we are actually finding all the indexes of a number. The major challenge, or I would say learning from this question, actually lies in these four, I would say, steps. So the result have to be declared, or actually we have to be given as follows. The first one, okay, so the first function which we are going to write, it's going to print the indices. Okay, so it's going to print the indices. The second one, it's just going to update the answer in the list which we will be provided. The third one will be updated the indices or the answer in a global list. And the last one will be returning the answer as a new list. Now I know that this will be a little bit daunting as of now, but we are going to take them one by one and make sure that we are able to get the answer. And meanwhile, also learn the very important concept in all, I would say, these variations, so that in future, whenever you are given any question, so you are actually asked question like this, where let's say you have to print the subsequences or return the subsequences, or maybe let's say append the subsequences or anything to a particular list which is already been provided. So via this question, my aim is that I am able to actually clear all of these variations which we get in recursion, and let's say when recursion is actually combined with any collection like list or a string, okay, so that in future you will be able to solve those questions. Now, please make sure that you understand each and every variation very nicely, because the same will be helpful to you when you are solving the question in interview or let's say on any other coding platform. So let's get started. In this video specifically, we are going to work on the first one, which is print the indices. Okay, so let's start it, everyone. Let me add a new file here. Great. So I'm just going to copy this particular thing and pay attention, everyone. Def print all indices of element. I'm going to get L1 and I'm going to get X. Great. So yeah, I think this works. We can just write pass as of now and run the same thing. And it seems to work. Like we're not getting anything. Yeah, because it is returning none. Now, I would like to explain you a few things before we begin. The very first thing is pay attention on this particular thing that, so as of now, we have already discussed that in a recursion, we can either return our answer or we can print our answer. For example, here as well, if you will see, we were actually returning our answer, but the question could very well have been where we were asked to print our answer. Okay. So these are the kind of variation which you should be aware of. Now in this particular question, if you will see, we are actually asked to print our answer. Okay, so now let us actually solve that as well. Like if we take an example, so for the very first use, I would say solution, if my array is something like this, 3 2 5, I think it was 8 2 8 2 1, and let's say if I am solving for 2, then my answer should be something like 1 3 and 5, right? This should be my answer. So again, it's always a very good practice to make sure that you're writing your answer. Now let us try to solve this, and let me explain you this, how we are going to do this. The base case is going to remain the same. If my L1 of length of L1 is equals to 0, then this time I'm just going to return. So I'm not going to do anything. I'm not going to even return anything, because I'm just required to print something, right? So on that note, I can even remove this print as well from this function, because my function will take care of printing everything. Okay, nice. Now the next part, if my L1 of 0 is equals to X, I can print maybe 0. Okay, so as of now, maybe I can print 0, and then maybe I can call this particular method, and it will, call this particular function, and it will take care of rest, right? Great. So let us run this, and we see the answer we are getting is 0 0 and 0. I think this should be pretty, I would say, understandable. The reason is that we face a similar kind of problem in first index of a number, where we are getting this as 0. Now the solution for this particular thing is a little tricky. In the last solution, if you remember, we were getting something in return, right? So we were getting this answer from recursion, which was getting returned. But in this particular question, or this particular, the way we have to write function, we are not getting anything in return. So for that, we have to make sure that we are able to handle this while we are calling our function. But as of now, I don't see any way. If we are kind of cutting our array or list, then how can we pass on that information that, okay, which element you are, or which I would say you have to print if you find that particular thing, right? So we can actually do one thing, and that will be a very good optimization as well. So what I'm suggesting that we do is, when we are sending this particular array or list, along with it, let us send an index as well. Let us send a starting index as well. Now, instead of actually slicing our list, at each and every function call, maybe we can just ask our function to take up the next index. So what I mean by that is, when I'm calling by this particular function, I will be calling this with the index of 0. So it will work on the very first element. When I make this particular next call in my recursion, I will just do index plus 1. So the next call, which I'm drawing in blue color, it will be aware that it has to start from 2. And instead of slicing my list, I can just let it as it is, right? Because now index is in a way telling me that from where to start. Intuitively, you can think of it like this. Let's say if you have a movie, then there are two ways I can tell you to watch half of the movie. Either I can give you the second half of movie by like cutting the full movie, or let's say by using some trimming tool to trim the second half. Or I can tell you that, hey, from 1 hour 30 minutes is from where you can watch. So I'm telling you the index position that you can start watching from 1 hour 30 minutes. And from there, you will actually be able to see the half movie. Now, one more thing to note here is that, of course, the second one, this index approach, is better because in this, we are not creating copies of our list. In the slicing answer or slicing way, we are always creating multiple copies of our list. But when we are giving this index, we are able to actually send the same list. And that's, of course, in some way will be saving, I would say, some space. Intuitively, you can again think of that if I'm creating a movie, let's say if a movie is 3 hours long and I'm giving you by creating a copy, which is 1.5 hours, I am in a way handing out two movies, right? Instead, I could have just given you the same file, same movie file, and ask you that, hey, you can actually watch from 1.5 hour time stamp. Okay. So I hope this is clear. Let me just quickly show you this as well. What I mean exactly by this. So let us just copy this particular code. Or first, let me show you in this what exactly I mean. Now pay attention everyone, what exactly I mean. Let us solve this question of first index, and that will help us to clear. So see, when I was actually checking for this and when I was calling this particular thing again, my list one is now actually pointing to another list. So slicing actually creates another list, and somewhere in the system, of course, that will be taking up the memory. Now again, we don't have to think of this as of now, but in future module, I will be teaching you about time and space complexity. So, but you can always think on an intuitive way as well that yes, space is gonna get increased, right? So now in the next again as well, we are gonna create another list. Now what if our list has 1,000 of these elements? Again, 1,000 of such copies are gonna get created. So the solution, or the way which I am suggesting, is what we can do is we can just have this index, okay? Or we will be passing this index as 0 initially. I can catch this index here and I can just check on this particular index and return the same as well. So I'm just checking at a particular location, particular pointer, which is denoted by index, and I'm just basically using the same thing to return in my answer. And now I can just do this and remove this plus one from here. So what's going to happen now? Pay attention everyone. What's few things which are going to improve here, and let me just send the full list as well. So pay attention. Once again, what is the error? Yeah, makes sense. So just one problem which we made was that here now when we are returning this particular thing, we have to make sure that, the base case is fine, because see, now we are not slicing our list down, right? We are not slicing our list down. So how can we say that length of list is going to become 0? So for that particular use case, we have to actually write our base case in a different manner. I think the base case can be something like this. If my length of L1, okay, let us quickly think of base case here everyone. So because now we are dealing with index, the way we can handle our base case is something like this. If my length of L1 is gonna be equal to index. The reason for this, if you think, is that so let us take this as an example again, and please pay attention, these are very important things. When we are dealing with this 3252, I know the index is gonna start from 0 and the last element is gonna be at third index, but the length is gonna be 4. So when my length and my index, they are equal, basically when I'm pointing here, that is where I should return, because this is anyway gonna give me the error. And that was the reason we were facing the error when I tried to run this code. So when my length is equal to index, just try to draw out, I would say 5-7 your test cases here, and you will understand why this particular base case works. Because when the index will actually reach equal to length, then this will be the case, right? So if I write L1 and length of L1, I always get an error, right? Because this length of L1 is pointing here where there no element is present, because we do zero indexing. Okay, so with this as a base case, I think we should be more than good to get our answer. So pay attention now, everyone. Let me visualize the execution. And I want to show you one more thing, so pay attention. This time again we are calling, that is all good. But this time I'm just checking with respect to index. Okay, so I'm just checking with respect to index. So let us move forward. Now when I'm calling this particular function next, you will see that we are not creating any new list this time. We are actually using the same list. This is pointing to the same list. When I similarly go forward, again I'm not creating any new list. So you can see that how my functions are now recycling the same list as it is. And all is good in this particular way, right? We have this index. See, now it is pointing at index 3. 3 is still there. The second, I'm going to send the index as +1, which is going to be 4. I'm going to come out of this particular function, because again, this is a problem, right? And because I'm returning -1 here, the same is going to get returned. Right? The same is going to get returned. It's going to return -1, -1, -1, and finally the answer is -1 as well. Okay. So I hope with this, you are actually clear on this particular, I would say, case on what exactly have we changed in this particular implementation. So let us just copy this and let me even update it here. So you will see the same in notes as well. First index, and let me make it better. Reason it is better is that we are able to now use index. We are able to just use the same copy, recycle it. If this is clear, then actually this code will become a lot understandable as well. Just pay attention, everyone, what exactly is going to happen. One more thing, always remember that if let's say the definition of your function is like this, where we don't have any index, you can always create a helper function. Now the helper function, the way you have to create is something like this. So you can just copy this name maybe. Okay, you can call this and let's say helper. And now you can pass everything and what extra you want to pass, and you can define the function again. So I will repeat what exactly I have done here, everyone. See, the way I was given this function, it was not having index. Now, yes, I could have changed that, but in many places, in an interview, or I would say in any platform such as LeetCode, many times you are not able to change the function, right? So maybe you can either define a default argument. Yes, we are aware of default argument as well. But if still that is not something which you are comfortable with, you can actually create a helper function as well. In the helper function, we are just changing the definition. We are just including this index again, and I'm passing this index as 0. Now, one major problem which again you can face is that how will you know how you have to create the helper function? Well, anytime you feel that there is something extra which you want to pass in your recursion function, but the same is not in the definition given to you, you are free to create your helper function in that scenarios. So more questions you do, more you will understand them. But always remember that, let's say if something is there which you expect to be coming in your function, but that is not being provided in the current definition of your function, we try to create a helper function. Okay. So again, through this question, many of these kind of doubts will get clear, and you will be able to solve even medium to hard level question once you understand this properly. Now, what I have to do is, if I've got my index, my base case first is going to be something like this only. The base case is going to be the same. I can just return. I don't have to print or do anything. Okay. Next part, I think it's pretty easy now. If the first one was clear, then it is pretty easy. If my L1 of index is equals to x, then I'm gonna print, right? Then I'm gonna print index, because this time I have the index, and I'm gonna call this with L1 x and index plus 1. Okay, just one thing we forget in this particular thing, it is right only. So we are not printing this, so we are returning it here, right? This time we are not returning it. This time we are not returning it. If I have to now pay attention everyone, if I have to just return the first index, then I can return from here, because the second I get the first index true, then my code is all fine, right? But I'm not returning it. So what will happen because of that is the future calls are gonna get made. So let us try to run it once. Everyone. So it is actually running from here. So if you will see, print indexes of an element. Okay. So it is running from here and we are able to see the answer. So let me just quickly run it again for you. Now just let me remove few elements so that you are able to see this. The answer is going to be 1 and 3. Okay, but let us see how exactly that's going to go. So pay attention, this was our function which was the helper function. Then print all indices of an element, we call this. This function in turn is going to call print indices of an element helper, which is going to take care of everything. I'm going to get index as 0 and L1 is this. And see, now this how this L1 is getting reproduced, right? So sorry, recycle. We are not creating any new L1, which is of course a very good thing. Now first the index is 0. Of course the base case is not right as of now, so we are going to go to the next condition. Then again we are going to move forward. Now this time fifth condition is actually going to be true. So x2 and index of list L1 is also true, so we are going to print it. Now if I would have returned at this point, I would have solved for first index of a number, but I'm not returning. So again the function call is going to continue. Okay, this thing is again very important to understand. In the next function call, again this is true, so we are going to print 3. Okay, so if you will see here, index is 2 and x is 2. Okay, sorry, this time L1 is 5. So index L1 of index is 5, so we are not going to print and we are going to move forward. Okay, this time we are going to print and you can see in the answer that 3 is going to come. Okay, and in the last one, when we make this last call, when the index is 4, and you will see that all the L1, right, this L1 is basically being referred to by each and every of these variables. So that's a very good thing, because we are now handling everything with index. Now because the size and the index are same, we are going to return. So pay attention, length of L1 is 4 and index is 4. Do we have a fourth index here? No, right? So this means that our base condition is actually holds very well. Now you can return the same, and because all the work have been done, we can return the same, right? We can return. So I hope with that it is clear. Now just a very small thing which I hope all of you would have guessed by now. If I want it in reverse order, I can just ask recursion to do its work first. And everything will be in reverse order, because this time I am asking recursion, hey, go and check for this particular index and print your answers, then I will do my work. Okay, and again in this way as well, if we are able to find an answer, we can return and we can make it for last index of a number, so that you can be very good to print, or you can actually be very good to modify and print that. But yeah, this is how we are actually handling this particular use case. Okay everyone, so with that I hope the print one is clear. Now I know this might be a little bit tricky, because we have discussed few things here. I'm going to discuss what all we have actually seen here. So first we have seen that, okay, the recursion question can be asked in a different manner, same question. Second is how we are not slicing our list and using index, and how that is a little beneficial. Third is that we can create helper function. Okay, so whenever we want some extra arguments or parameters in our function, we can of course create a helper function. And the last one is that based on how we want the answer, we can actually do our work first, or make the recursion call first, and just write our code based on that as well. Okay, so with that I hope the print the indices one is clear. Again, please make sure that you are drawing the recursion tree for this yourself, and try to code this once again with I would say yourself. And in the next video, in the next series of video, we are going to solve the variations of these problems. Once we solve all the variation, you will be at a very good place to solve any question provided to you for recursion and arrays. Okay, so let's meet in the next video everyone. Thanks a lot.